Good day, everyone. I'm Rico Beme, and this is Brainbytes AI, a training assessment for MLRP 122 DevOps. Together with Honey, Darren, and Adam, we built a real-world platform that aims to make AI-powered education more accessible for Filipino students. Setting the stage. Our mission isn't just about technology. It's about democratizing AI-powered education, specifically for Filipino students through accessible, culturally relevant AI tutoring with a mobile-first approach. Today, I'll demonstrate how we've achieved three critical success metrics: complete system functionality with live demo, a robust automated deployment pipeline, comprehensive real-time monitoring, and operational excellence that would make any production team proud. So for our technical foundation, let's talk about technology stack. Our front end uses Next.js with TypeScript for lightning fast, mobile optimized experience that works even on slower connections. The backend runs on Node.js with Express for scalability, while our AI service integrates with Grok API to provide contextually aware tutoring service. For our DevOps stack, we've implemented industry standard tools, GitHub Actions for CI/CD, Heroku for deployment, and a comprehensive monitoring stack with Prometheus and Grafana. Every component is containerized with Docker and orchestrated through Docker Compose. So let me walk you through our architecture. So starting from the top, we have Nginx as our reverse proxy, handling SSL termination and load balancing. This ensures secure, fast traffic routing to our three core services. So our front-end service runs on port 2001, delivering server-side vendor via components optimized for Filipino students' devices. The backend API on port 3000 handles all business logic and authentication, while our dedicated AI service on port 3002 focuses solely on delivering intelligent tutoring experiences. For data persistence, we use MongoDB for primary storage and Redis for session management, both chosen for the performance under varying network conditions. Our monitoring stack, Prometheus, collects metrics from every service. Grafana visualizes them in real time, and Alert Manager ensures we know about issues before our users do. The key benefit, each service can scale independently on Heroku, preventing cascading failures while maintaining full observability. Now let's go to our cloud deployment. Running live on Heroku with separate staging production environments. As I speak, Brainbytes front-end production, Brainbytes back-end production, and Brainbytes AI production are serving real users. Our staging environment mirrors production perfectly, ensuring every change is validated before it reaches our students. So for our cloud deployment configuration, our deployment strategy centers on automation and reliability. Every push triggers GitHub Actions workflows that include security scanning, comprehensive testing, and health checks. We use MongoDB Atlas in Singapore for optimal performance in the Southeast Asian region. So the beauty of this setup, developers can focus on building educational features, while our DevOps pipeline ensures security, quality, and reliability automatically.
Let's examine the engine that makes all this possible, our CI/CD pipeline. Every code change goes through a security-first approach. ESLint and Prettier ensure code consistency. Security audits catch vulnerabilities, and secrets scanning prevents accidental exposure of sensitive data. Our testing strategy is comprehensive: unit test, integration test, and end-to-end testing with real MongoDB connections, and performance testing specifically designed for Filipino connectivity conditions. Here's what makes us production ready. The main branch requires manual approval before production deployment, ensuring human oversight for critical changes. Meanwhile, the develop branch auto-deploys to staging, enabling rapid iteration and testing. So the result? Multiple validation layers that prevent broken deployments while maintaining development velocity. But deployment is just the beginning. Real production system requires comprehensive monitoring, and that's where our observability stack shines. We collect metrics at every layer. Node Exporter monitors system resources. Heroku provides platform-specific insights, and our custom application metrics track educational analytics that matters to our users. Prometheus serves as our central time series database, while Alert Manager provides intelligent notifications. Grafana transforms raw metrics into actionable insights through rich real-time dashboards.
So now let me show you our application for the Brainbytes app. Let me start the Docker. You can use this script to start our app, or you can use the conventional Docker Compose up dbuild. And if ever you are encountering errors with the Docker, you can just use this restart clean path to restart the Docker. And also, make sure your Docker is open. It's now restarting. So while it's restarting, let me show you the live application. So if ever you encounter error here, just restart because I'm using Echo Dino and it will sleep. The app will sleep if it's not in use. So here you see login. Just log in these credentials, or you can sign up a new account if you want. Signing up. So it will redirect to the chat interface. You can see here we already have the history conversations. You can just simply choose this or add a new chat. Let's add a new chat. Let's say what is DevOps? So it answered. It also has the capacity to remember your first question or your previous question, so you can just follow up any questions. So let's say, how difficult is it? Yeah, so it's answering. Aside from chat, it also have a dashboard and profile and learning, where you can add subjects, manage the subjects. So let's now log out. That's how our Brainbytes application works. Let's go back to the Docker. See, we have here all the services that we are using, including the monitoring. Before diving into the monitoring, let me show you our GitHub workflows. So for the GitHub workflows, let me show you our code here. As you can see, we have 3 different workflows. You have the code quality, CI/CD, which is our main pipeline, and of course our deploy to Heroku. So code quality is the first workflow that will be triggered on push and pull requests on our main and development branches. And it will also run daily security scan at 2 a.m. So let's move on to our GitHub actions. Let me trigger the code quality workflow. Let's use the main branch, choose full, and then run workflow. Okay. So code quality and security scanning includes lint and format check for AI services, back-end and front-end, and also it will simultaneously do security vulnerability scan, code analysis, secret scanning, and quality summary. So now the code quality checking is already done, and you can see here it has already created a quality summary report, and we see that we don't have any security vulnerabilities. Now moving on to the CI/CD pipeline. So after the code quality check, it will then trigger our CI/CD pipeline. So inside the CI/CD pipeline, we have first we'll first check the code quality status. So if it's failed, of course, it will not continue with the CI/CD pipeline. It will fail, and then so after this code quality check status, it will set up all the dependencies. Then it will do test matrix to our node 18, 20, and 22, and of course, simultaneously it will do E2E testing using our playwright and performance testing. So here, showing you, it's now installing a playwright and performance testing here, installing dependencies. So after this is finished, it will create test summaries and send notifications. So now here, it has already finished the E2E testing and performance testing, and it has already created a test report and sent notification. Below here is the result of our CI/CD pipeline summary, and you can see that everything is successful. So now, let me show you what's the next process. So after the CI/CD pipeline, it will trigger the deploy to Heroku. So it will first check the CI/CD status and deploy to staging. So for the deploy to production, it cannot be automatically triggered since it requires approval from the QA and the project manager. So we will need to manually deploy it. So assuming we have already finished deploying to staging, let me show you how to deploy to production. Just click here, choose main, and then choose production and run workflow. Let me refresh. Now we have now it's deploying to production, but first it will do quality checks first, and then see this. So now let's fast forward. We have now successfully deployed our Brainbytes AI into our production and staging environment. Now let's move on to the monitoring. So I have here the C advisor, our alert manager, our Prometheus, and our Grafana. Notice that it is all running via Nginx proxy. So for the Grafana, just use these credentials to log in. Once logged in, go to the dashboards, Brainbytes, and now you will see all the dashboards that we have created. We have the application performance dashboard, system overview dashboard, user experience dashboard, error analysis dashboard, and Heroku monitoring dashboard, and resource optimization dashboard. So for the Heroku monitoring dashboard, since Heroku does not support Prometheus and Grafana deployment, we are just using or scraping data from Heroku metrics to use to our monitoring. So I have created an .env here to add our Heroku API key, and then let's go back. For Prometheus, to check the target health status of our services, just go here, target health, and make sure everything is up, and also our rule health. You can see everything here, and our alerts, of course. So notice that everything is inactive and there are no alerts yet. Also with our alert manager, nothing, and our Grafana is clean, still flat. Now let me trigger an incident simulation. So what we are going to do here is we are going to generate HTTP 500 errors at the rate of 10 per second. I have created a script, simulate incident simulator.js. So let's now trigger our error. Notice that it is trying to start the errors. Let's check our Prometheus. It will take time, like 2 to 3 minutes before it starts to show. So let me stop for now. Let's check our error rate in Grafana. Now it's starting. See this? Let's see last 5 minutes. See? You can also check last 15 minutes. Let's go back to our Prometheus. Still pending. You can also check the status. Let's see. Let's use this code. It's still pending. You can just check every so open. Well, it's still generating there. So now you've seen how it is generating errors. Now let's try to resolve the error. Um, Okay, so now we already have the three error reflected in our alert manager and also in our Prometheus. You can see this, it's already firing. You can actually click this and check graph. It went up here. Let's go back to alerts. High error rate. See, it's firing and it's critical. Now, let's try to resolve this error. I have created here a script to resolve our high error alerts. Resolve. That's now generating normal traffic to clear alerts. So what's happening here is that it's the resolution process stops generating new errors, so it will generate 1000 plus successful HTTP results to dilute the error rate below the alert thresholds and waits for the metrics to update. So let's wait until it's finished with generation. Now we have already finished, it has already finished resolving high error rate. Let's check our status. You can use this code. See, it has cleared. We can also check manually through our Prometheus. Let's now, again, clean. And also, let's check here. No more graph. It went up when we triggered and then it went down. And also our alert manager. Let's check if we still have the alerts. So alerts were silenced. And also let's check the graph on our Grafana. So when we triggered, it went up, and then when we resolved the issue, it went down. So that's how we do our monitoring and resolve it.
Now, let me be completely honest with you about our journey. Building a production-ready system while managing 4 other subjects meant 60-90-hour weeks become our norm. We faced unrealistic workloads with zero ramp-up time, where everything felt urgent and there was no time for mastery. Stress, burnout, sleep loss, and fear of failure became constant companions. There were moments when copy-paste felt like survival, not cheating. We questioned whether we could deliver something truly production-ready under these constraints. This journey taught us invaluable lessons that extend far beyond DevOps. Production ready means planning for failure. Every system will fail. The question is whether you will be ready. Our monitoring and alerting isn't just nice to have features, they are survival tools. Documentation is a love letter to your future self. 6 months from now, you won't remember why you made that architectural decision. Write it down. Culture eats strategy for breakfast. The best DevOps tools mean nothing without a team culture that values quality, collaboration, and continuous learning. Real world constraints breed innovation. Limited time and resources forced us to make better architectural decisions and focus on what truly matters. Technology serves people, not the other way around. Every technical decision should trace back to how it serves Filipino students' educational needs. We plan to introduce smarter AI tutors that create personalized learning paths and offer timely encouragement to keep students motivated. We're also expanding our subjects to include Filipino history, literature, and cultural studies, bringing local context into a learning experience. And to reach more students, especially in remote areas, we aim to add offline mobile access and voice based interaction for easier and more inclusive learning. In closing, Brainbytes AI is more than just a project. It's a step forward to a future where every Filipino student has access to quality, personalized education through technology. We've proven that students can build real working solutions that address real problems. With continued improvements, community support, and dedication, this platform can grow into a powerful tool for learning across the country. This is not the end, it's just the beginning. Thank you, and I'm now ready to take your questions. All right, so thank you so much for your question. So first, we will need to address the first question with what happens to Prometheus when it does not receive any data from the containers? So when Prometheus stops getting data from a container, it simply assumes there's a problem. Either the container is down, the service isn't responding, or something's wrong with the exporter. It marks that as a gap in the timeline and flags the service as unhealthy. On our end, this triggers an alert through Alert Manager so we can investigate it right away. So most of the time, it's either a crash, a config issue, or sometimes just a deployment hiccup. But the good thing is we find out within seconds, and our dashboards clearly show where the issue is coming from. And with your second question, how does Grafana help in monitoring the containers? So Grafana basically takes all the numbers Prometheus collects and turns them into a live dashboards that are easy to understand. We can track CPU, memory, traffic, even how long our AI service takes to respond. So instead of digging through logs or guessing what's wrong, we just open Grafana and it's all there. Color coded with alerts if anything goes past our thresholds. It's help us also catch slowdowns or spikes before users even notice. And for a team juggling a lot of moving parts, it's like having a health monitor for the entire system in one place. So I hope that answers your question. And again, would like to thank you for listening to our presentation. And this is again Group 2 for the DevOps. Together with me, my teammate Zaira, Rico, and Honey. Have a great day.